Christopher Harrison. This is Web Wednesday, the show where I bring on people that are much smarter than me to talk about various things web dev related. Now, it's been a little bit of a spell since I've been here. We had Build a couple of weeks ago, and then a couple of good friends of mine, Anthony Chu and Burke Holland, came in and hosted last week. But this week we are back to normal, and we're talking about something that we really haven't covered much at all. In fact, I shouldn't even say much at all. We haven't covered at all yet on this show, which is Go. Or more specifically, we'll be talking about Go inside of serverless apps, so Azure functions in particular. And I'm very happy to be joined by a coworker of mine, a friend of mine named Chris Noring. I've had the opportunity to work with him on a couple of different projects, including a Vue.js learning path, which you can find over on Microsoft Learn. And we're coming out with a video series. It's going to drop on June 30th to talk about Vue as well. So definitely check those out. But that's not what we're talking about today. Today we're talking about Go. Today we're talking about serverless and Azure functions. But enough of me babbling. Let's go ahead and get Chris in here. So Chris, thanks again for joining today.
Thank you, Christopher. I really appreciate the invite, and I'm really glad to be here, and I'm super excited to talk about Go and serverless.
Fantastic. Well, I always love to start with the kind of basic question, if you will, which is, how did you become Chris Noring? How did you get into becoming a developer and kind of find your way to Microsoft? What got you to here?
Very good question. So that begins a few decades ago, and
I feel that.
I would say, I would say at the age of 14 or 15, I didn't even know whether I wanted to be an engineer or something else. I mean, I had all sorts of plans of being a teacher, a history professor, God knows what, right? I decided somewhere along the way that, engineering, tech, why not? Why not challenge myself? Because I just loved reading, writing, all of those things. So I went through university, took me a few years, but I studied computer science. And fast forward a few years, I did a lot of .NET, spent a decade on that. And I ended up with probably 2016 when I was saying, hey, let's not just be a developer anymore, but actually learn actively. So I started to organize this software craftsmanship meetup. So I did that, and there were maybe 20, 30 attendees. It was a very small, very humble little meetup. And after a while, I thought, hey, why not interest myself in JavaScript? Because JavaScript is super cool, right? And at that point in time, AngularJS was a thing. And it was actually one of the first frameworks that I tested out, because I came from C#, came from the backend, and I thought front end, I'm super productive. So I took it upon myself to organize this AngularJS meetup. Along the way, though, I picked up a lot of different frameworks because I love them all. I love Svelte, Vue, React, you name it, right? So I think that's the reason why you and me and some other nice folks did some videos on Vue, because I just can't get enough of JavaScript. I know we're here today to talk about Go, but I'm just generally excited about programming languages, and hopefully I'm able to convey that. So yeah, many meetups later, many conference talks later, and you and me and some other folks writing stuff, recording videos. So here I am in 2021. So
I love that. I love that. That's fantastic. And I agree with you that, I love exploring new frameworks, and I think they all have something to offer. And like one of the things that will always get under my skin is whenever somebody comes in and goes, oh, you should only ever use React, or you should only ever use Angular. And not only is that, just a bad approach, I think, to life in general, like, get out and explore, but it's also just not the right approach to development, that each one of these frameworks has its advantages, has its disadvantages. And there are certain scenarios and types of projects where using one framework over another is going to be the way that you want to approach it.
Yeah, for sure. I mean, I've always seen frameworks as a tool, right? So, I mean, I've been talking about Svelte at conferences, React, Vue, and Angular, right? So I don't really have a super strong preference. I mean, it really depends. I mean, if you're coming from background as a full stack, maybe Java, maybe C Sharp, it makes sense to adopt the whole TypeScript thing, and that leads you into Angular, maybe. But there's really good TypeScript support nowadays in Vue and React as well. So it's really what you want to do, right?
Exactly. And honestly, like my favorite framework will change rapidly. That I fell in love with Knockout back a long time ago, and then I really loved Vue, and I've started exploring Svelte a couple of months ago, and I that just feels so natural to me that I very much love Svelte, and I'm sure in a couple of other weeks I'll have something else that I'm really excited about. I just started exploring Astro earlier today, actually, and that looks pretty interesting. So yeah, like ask me in a week, and I might have another favorite framework.
I haven't heard of Astro, but I'm very excited now. So I need to pick your brain on that one.
It's interesting. It's put together by the same people who did Snowpack and something else. And I think there's some involvement from Tailwind as well. And it's designed to be sort of that, kind of similar to Snowpack, where it's an all-encompassing bundler and everything else. But what's special about it is it's designed to bundle everything to just HTML and CSS, so that by default, it's actually going to strip out as much JavaScript as it possibly can. So that way you're just serving those static files as much as possible. So it's pretty slick. And what's also really nice is if you want to then do dynamic development, you can then just bring your own framework with it. So you're using Astro as sort of like the container for your project, and then you can bring Svelte or you can bring Vue or React. No support yet for Angular yet, but you can then bring the framework that you really like into it and just keep coding with it. It's pretty slick. It's pretty slick.
I'm gonna start Googling this somewhere and then just see what it's about. I think.
Yeah. So there's how you can spend tomorrow.
Yep.
But let's talk a little bit about what it is that we're here to talk about, which of course is Go and serverless. And let's start with kind of the basic, the most obvious question, I think, which is, what is Go, or Golang as it's sometimes known?
So Go or Golang is a programming language built by Google, and it's built to address the shortcomings of C++, right? So it comes with a feature set that's missing in C++, and it's also very, very fast to compile. And it has a speed that's comparable to that of C and C++. But it's also promising to be easy to read, which I'm about to show you soon. And so easy to read, in fact, that it's like Python, or that's how they're selling it. And I kind of like the word, when they say that, because I really enjoy Python and the fact that it's so easy to get started with, prototype, build your thing. So if something is compared to Python, you got my attention.
Yeah, I'd certainly agree with that, and the reason that I'm so wide-eyed here is, like, I've done C++, and by that I mean I took a semester of C++. I barely made it through it, and then just made a promise to myself never to go back and do C++ again. That I found it so confusing, and so to say, hey, this is a language that's supposed to address the shortcomings of C++, I'm thinking that complexity, but yet the syntax is similar to Python. You've certainly got my attention. I'm intrigued at how this can actually happen. How can you take C++ and make this like Python?
Yeah, for sure. I mean, I think it's the fact that you're so close to the metal, right? And I mean, one of the things that C++ does for you is the whole memory management is your problem, right? So
Right.
you and me both, we started with C++ and it was painful, and we did any other language except for C++, right? That's my first language. My second one is Java, and then C Sharp, and I'm staying there, or JavaScript as well. But yeah, so Go is very close to the metal, which means it's super fast to execute and makes a lot of sense to use it in like web servers or things where you really need that speed, right? So this is where Go is supposed to be used. So it's super easy to say, hey, can I use this like it's JavaScript? You can, but you're probably better off using Node.js, right? But if speed is a concern, Go is your language for sure.
Okay, and we should make sure for anybody who's not familiar with the phrase close to the metal. So what we're talking about here is some languages like Python or like JavaScript are interpreted languages. So what's happening at runtime is there's an interpreter that's going, oh, okay, this is what we're supposed to be doing, and then it's sending those messages onto your operating system to tell it what it is that it's supposed to do. But when you're talking about C++ or C# even, which does compile down into that intermediate language, which is sort of like a step away from assembly, or with Go, that it's as close to the language that the operating system is going to speak natively as possible.
Yeah, for sure. I mean, if you compile a Go program, I think you get ones and zeros, right? You get machine code. So, even there, so I think it's really great that you kind of explained that term, because I don't think it's obvious to folks when you select a language, why is this one fast and why is this one a bit slower, right? And even then, it's not the entire truth, right? Because even if you have an intermediate language, there are tricks you can do to, speed it up. So in today's world, I think you're pretty good with a higher level language that's not that close to the metal, and in most cases, right?
Yeah, I agree completely. Like I always like to make this this admittedly very glib statement, which is that developers are expensive, RAM and processors are cheap, relatively speaking, and a lot of times what you're really looking for is time to market. So how fast can we develop something? And if that's what you're going for, then you can sort of overcome sort of some of the performance issues that you're going to have with like Python or JavaScript by just throwing more processors at the problem and throwing more RAM at the problem. But obviously you are going to eventually hit a point where you can only throw so many processors at it, and it's just not going to give you that performance. And so then at that point, you need to turn your attention to a language again, like Go, like you're mentioning, or C++, something that is going to be down on the metal and going to give me that better level of performance.
Yeah, for sure.
So how does, I'm trying to figure out what question it is that I want to ask here. How do I write a Go program? I want to use that and then sort of like spin into getting into serverless here. So how do I write a Go program?
Yeah, I mean, it's you kind of start with a text file like you do in a lot of code languages, but you do need to install a runtime. If you're on a Mac, you can install it via Brew, and I believe if you're on Windows, there's some installer package. Once you're there, once you're set up and running, you just need to name that file .go, right? There's also a way to, once you grow up a little bit in your knowledge, to kind of use a more project-based approach. We're not going to be that far today, but rather show I have a very simple program. You start with that text file, you name the file ending .go, and you start typing. And as with a lot of programming languages out there, there's always this entry point, right? There's always this first function that you need to call that kind of spins up the entire app, and Go is no different. So kind of compare that to a Java program or C#, you have an entry point. You have that first main function, if you will. And it's the same thing with Go, right? You kind of start there. Start with a text file, have that entry point, and fire away.
Okay, all right. So let's then start to bring in the other part to our conversation, which is serverless. So what is serverless? What does that mean?
Serverless is very interesting naming in the first place, right? Because you think there's no server. So what we mean by the name is that the server is not in your basement. We mean that it's in the cloud instead. So if we go away from the naming of the whole serverless and say, what does it mean? Well, it means it's event-driven programming. And that means that your code is only going to run when a certain event that you want to listen to happens. And what that event could be is, for example, a web request. Someone says, hey, I want to go to /products, or maybe there's a queue message, or maybe there's a database that says there's a new row. There are all kinds of events that can happen in the cloud, and you can sit there with your serverless function code and say, I care about this event. And if this event happens, then I got a few statements, and I want you to run those statements. So that's essentially what Go allows us to do, is to listen to something interesting, and run code because of it.
Okay. Now, I could still do that with just like a normal web server. So why would I use serverless to do something like that?
Well, so a web server is kind of limited to a web request, right? It's really good with web request, but what if I want to listen to a queue message? How would a web server even attempt to do that, right?
Right.
It needs to speak the protocol of the queue, or maybe if it's a, some other type of event that happens in the cloud, you need to speak that protocol, and that means that you need to write a lot of code to connect to that thing, listen to that thing, parse the message in a way that's very specific for that event type, right? And because serverless, at least on Azure, exists as a framework, that means that all of those connection points, all of those how to interpret the message, that's written for you, right? So the whole point is to have a Lego almost, right? Event type, here's a message type, and off we go, right?
Okay. So where would I use serverless? What types of applications would I use serverless in?
So I usually have an example where I say, hey, if you, for example, have an e-commerce app, I tend to tell people, okay, everything in your app is not going to run 24/7. You definitely have business flows that are very seldom. So I usually tell people, I'm sure you have a onboarding customer flow, right? Every time you get a customer, you have this specific thing that needs to run. And it doesn't happen that often unless you're Facebook, right? I mean, every time we get a new customer, it's probably once every 2 weeks or something like that.
Right.
When that happens, we need an entry in a database. We need an email sent out that says, welcome, whatever the customer's name is. There's all these small things that needs to happen, but they're seldom. So one aspect of serverless is that it should only be reactive code, right? Something specific, business specific happened, that new customer happened. And because it happened, I need to run that code. So one of the first things I tell people to do is identify those scenarios. And once you have those, start to encode those as a serverless app. But there's also another aspect with serverless that's interesting. It's not only seldom run code, but because it is seldom run, it means if you think about the cloud as a hotel for your app, if it's up 24/7, you're likely to pay a certain amount. But if your app is only supposed to run a few seconds every month or every week, your cloud bill is going to be less, right? So as part of serverless is that it's very cheap. So it makes sense for people to save money by identifying those parts of your app that you can just yank out, make serverless, and say, hey, my cloud bill actually went from here to here.
Okay. All right. So it sounds like then I'm looking for things that are going to happen periodically, but might be kind of expensive. That you were mentioning, like I need to update a database and I need to send an email and I might need to call some other services. And like that's a fair amount of work when a new customer joins, and that's not something that's going to happen periodically. So I need to make sure then that I'm not paying for the processing power that it's going to take for that constantly, that I only pay for it when that happens.
Yeah, for sure. I mean, so we have this notion, at least on Azure, but I'm sure other clouds has it as well. But when you run that function app, you only pay for the execution. And normally when a function executes, it takes maybe a second, right? And it's using some ROMs. And in fact, the first million calls you do to a function app doesn't cost you anything. But what you do pay for is first million calls.
Wow.
So you can imagine that the serverless part here is not the expensive part. But I just want to tell folks that just because you select serverless doesn't mean you have zero bill. I mean, you still have the whole storage bit, the fact that you talk to a database, that might still end up on your bill. But the serverless part is definitely, you need to work to build up that bill.
So if all of a sudden I'm getting a large bill for my serverless app that's just there for generating new customers, then that's probably a good sign that all of a sudden we've got a bunch of new customers. I should celebrate then.
For sure. I mean, one of the things we usually say about serverless is that it scales with your business. So if you got 1,000 customers, a week, and you have a large bill, it's because you're making a lot more money, and we're just here to take a small cut.
Small cut.
Well, I mean, you know how it is. A business is a business, right?
Absolutely, absolutely. So Manuel asked the question: can functions grow at the same scale of the load that it has to manage?
Yeah, I mean, so one thing we need to realize is when we're talking about Azure Functions, it's built on top of something. It's built on top of app service. So if you think about that as a model, that means that app service is usually where you have an app and you deploy it, like a backend API, for example. And so the model, the way that Azure Functions is set up is that you have the function app, which is your point of scale. So if you got 1 million people, that means that that function app will be scaled up in X number of instances. And inside of every function app, you might have n number of endpoints. So let's say you got 5 different endpoints to handle 5 different Azure function scenarios. So what's different maybe from other cloud providers is that we don't scale per function endpoint, but rather the function app. It's not a huge difference for you when it comes to the cloud bill. It's just how our inner model looks like at Azure.
Okay, all right. And Simeon asked a question, is it like an MVC? And I'm going to assume that the MVC is talking about his model view controller, unless there's another MVC that he might be referring to there.
So if we're talking about MVC.NET, for example, I would maybe compare it more to a web API, right? You have X number of endpoints that's running. MVC might be that you're using some kind of page-based server rendering model. So if you can move that comparison towards the web API, I think we have the right idea.
Okay. And then he follows it up with this question is, in a serverless, do you have API configuration on your endpoints?
Yeah, for sure. There's a lot of things that you can configure in an endpoint, right? I mean, one of the things you have is that you configure is the trigger type, because you can have an HTTP trigger or queue message trigger, database trigger. One of those configurations you do is that you configure how it triggers. And then you can also do like a route configuration. So if you want it to be /API/products, you can do that. Or if you just want it to be /products, you can do that as well. Now, another thing that you also configure is your outflow, because you can end up to send the input to somewhere else, right? So you have the notion of an input and an output. And as part of that output, you want to configure whether that ends up in a database or an Excel file or as a text message. So there are all these options for you, if you have the whole input-output notion.
Okay, that makes sense. Although I'm a little confused, you said both Excel and database, implying that Excel isn't a database. I'm kidding. I'm just making a joke purely for my own entertainment.
I just want to say this about databases because I'm writing a curriculum about it. If you feel like an Excel file works for you, definitely keep using it. If you feel like you need to grow up with your business and put that in a more performant database, definitely do that as well. So I would say this: I don't want to be the person that says, unless you have it in a SQL Server or an Oracle database, you don't have a business. You definitely can have a business if you're using an Excel file, and don't let anybody tell you different.
I could not agree more. In fact, Surly Dev mentioned exactly what I was about to say, which is that Excel is the world's most popular database. And that is a true statement. That is a true statement. Cool. So Manuela asked the question, which I think is like a perfect segue, and I swear he's not a plant. I'm not setting this up. But I asked the question, can we deploy a Ghost serverless function to Azure? So this is sort of like a perfect segue into how do I then create a serverless function using Go?
Right. Fantastic question, because that's part of what we want to talk about today. But let me just give you the mile-high view.
Yeah.
Normally, when you create an Azure Function app, you might use Visual Studio Code or Visual Studio or just a command line, and you end up scaffolding a project, right? So you have your function app. One of the first things you do is then to scaffold an endpoint. And by just selecting a template that is of type custom handler, you get all the normal bits that you would normally get with a function. You get the local settings JSON, you might get a configuration file, and some kind of code file. To get that thing to end up on Azure, one of the things you need to do with a Go app is to make sure that one, it's a web app, so it has the ability to talk HTTP and listen to an endpoint. And to make that thing deployable on Azure, you turn that into an executable. So you need to compile it. And once you've compiled it, you just need to point out that file in a certain configuration file that's part of your scaffolding, and off it goes into Azure, and it's going to work, because Go is just like Rust or whatever other code language you want to use. So our whole hosting model can actually operate on processes as well. It's not just, first party function code that works on Azure. It's also a process, and a process can listen to events.
Okay. Now, just to clarify here, do I have to compile my Go code locally and then I push up the compiled code, or can I just push up the source code and then as part of the deployment process, Azure will go ahead and compile that for me?
Don't quote me too hard on this, but okay. I do believe you need to compile it first, and then you deploy it to Azure.
Okay. That makes a lot of sense. And Manuel asked a question on ARM template. So ARM stands for Azure Resource Management, and it's a way that you can create things inside of Azure.
Mm-hmm. So. Yeah, for sure. So I mean, we have ARM template for Azure Functions, right? So you can just use them essentially. So as you will see, as I start to show how this all works, it's all about the configuration file and you hitting that compile command.
Okay. Well, since you've teed it up perfectly, let's see how it works.
For sure. Let's see here. Hopefully you can see my screen at this point.
Yep.
So I'm not going to put you in full mode because it's easier to have a conversation. We went through already that it's cheap, right? We can have 1 million free calls with Azure Functions, and we talked about the fact that it's all about events being produced and events that you can listen to. Now, I wanted to show you some of that Go code because we talked before, hey, this is actually easy to read like Python. So let's actually put it to the test. On your right here, you're looking at Go code. And if you remember Python, when you type functions, you hit the keyword def, and then you have like the name of the function, right? Mm-hmm. It's very similar in Go, but you use the func keyword. And you use the func keyword, the name of the function here on line 8, and you can see that it's saying sum. And then you have 2 input parameters, and at the end here of line 8, you have a return type. And in this case, it's trying to convert from a string, I believe, into an integer, and you end up producing a sum, right? You take 2 input parameters and produce the sum. And remember how I said earlier that you need an entry point into your program? That's on line 14. Okay. So as long as you have a function that's called main, this is where Go is going to look, right? So it's looking for that main function, and this is where the action happens. And it's from here that you need to do all the calls that you need to do to, execute the statements of your program. And yeah, we're taking input and we are doing a sum calculation, and we end up with a result. So this is as easy as a Go program can look. And I don't know about you. Do you think this looks as simple as Python?
It looks much simpler than C++. It looks pretty close to Python. The curly braces are obviously a little bit different, but I can see some of the similarities. Yeah,
so I mean, if you look at the top here, you see we have an import statement. So most languages have that, right? We have an import statement, so we bring in a few libs that will help us. The OS one helps us with input and output, for example. And the string conversion library helps us to convert between integers and strings and all kinds of data types. And once we have those imports, we're ready to go, right? Mm-hmm. And on line 8, we have a sum function, and on line 14, we have the main entry point. So this, in my opinion, it doesn't get that much harder with Go. It's just that you have different libraries that do different things. So maybe we can advance this a little bit. We talked about custom handlers, but let's just revisit that concept again and say a custom handler is a lightweight web server that's capable of receiving events from function hosts. And if you imagine that I'm saying that, and I'm saying that anything that has a web primitive or HTTP primitives, that's a lot of languages, right? So that means that you can almost deploy any kind of programming language that has HTTP libraries in it. So just imagine the possibilities of using something like Rust or COBOL or C++, whatever kind of language is your favorite that has an HTTP library that's capable of listening to events. All of that can be made serverless. All of that can be deployed to Azure. I wanted to show you another slide though, because it's easy to think when you have something that's not first-class support that, hey, you're not going to support all the nice things that Node.js or Python or PowerShell, whatever first-class support you have, right? But it does support triggers and it does support bindings. And if you're new to this whole serverless concept, let's just quickly go through the main concepts of serverless so we understand. We had someone ask earlier about the whole scaling and configuration and what is serverless, how does it work, and so on. So let's just reiterate that. So because we live on top of the app service platform, we have serverless that's built on top of it. So we build an Azure Functions app that's going to run with app service platform underneath. That means we got scaling for free. But so as we build our function app, that means we're going to put X number of functions in that function app. So, imagine that we have an endpoint that handles something and another endpoint that handles something else. If you look at the right here, you see that this is really how you should think about your function. So imagine in the middle here, you have your function. On top of that, you have your trigger. Now, trigger is the reason why this function is running in the first place, right? So someone did a web request or someone inserted something in the database. We have a moment of trigger, right? So our function has been triggered, but there's another concept that I want you to know about, which is bindings. I haven't talked so much about bindings, but I alluded to it when we said, I think you said, Christopher, that what happens, if I have a web request or a queue message, there's a difference, right? And I said that the difference is the fact that, well, to talk to a queue, you need a specific protocol and you need to know how to parse queue messages. Bindings is actually connection code that knows how to talk to X number of data sources, Excel, text messages, databases. You don't have to care. And bindings come in two flavors. One is input bindings, which is how we get data into our function. And output binding is what we're going to write to. So you have the notion of data coming in that's pre-populated. So if you have a binding towards a database when you activate a function, that means it's going to start knowing about 20 rows from a product database table, right? And if you have an output binding, that means you can have set it up towards an Excel file. So you end up reading data from a database and then ending up writing that same data into an Excel file. And all of this with like 5 lines of code. And this is the promise of serverless, right? That we can make it that simple. And just to show everyone that's on the stream, triggers can come in many, many different types. And as I said, serverless framework knows how to connect to all of these, right? It knows how to connect to a blob storage, Cosmos DB, HTTP. I mean, you see that the list is long, right? And then with bindings, as I said, it was connection code that you don't have to write. We have things like file connections, Excel, we have tables, we have OneDrive, we have emails, mobile apps, notifications. Just imagine that this is Lego, right? All of these Lego pieces are built for you, but only you know what you need to combine, right? So looking at how to build a web app in Go, then the reason why I'm mentioning this web app is because I wanted to show to you all, let's actually go to this mode. I wanted to show to you all how easy it is to build a web app in Go. And remember, we looked at that sum function. We had this very simple Go application, right? It took 2 inputs from your command line and it summarized those and you got an end result. This is almost the same lines of code and it's capable of serving up a web request. I mean, if we need to compare this to anything, I would compare it to like Node.js or maybe Python and Flask, or what do you think?
Sure. I was answering a question in the background, which Manuel had asked, and I'll get to that in a second. Ask your question again. I'll answer you, and then I'm going to bring up Manuel's question here.
For sure. So imagine that you want to build a web app, right? Mm-hmm. There are 2 main things that you want to do. One is to register a route, and the other one is to create some kind of route handling function, and you want to reply something, right?
Right.
I mean, I know, Christopher, that you know a ton of frameworks. You've written a lot about them and talked about them in video streams. compare this to Node.js or to Python and Flask. Doesn't this look very similar?
It does, yeah, it does look very similar because I mean, what I'm getting in is sort of the same types of objects that I would have in say like Node, where I've got the request, which is everything that's coming in. I've got the response, which is then what I'm going to use to write out, and then that handle function. Now I'm just saying, hey, here's my route, and then here's the function that I now want you to call. So again, kind of that very similar syntax. Yeah. Yeah.
Yeah, for sure. So it's quite readable, right? I mean, if you look at line 14, we set up a route. On line 15, we start up our web app. And on line 9, we're able to handle that request. And if you look at line 10, you see that we just print out and saying route hit. But we could easily read data from this request or its request body and say, okay, you tried to post something to me. The important part, why I'm kind of segueing into building web apps in Go, is the difference between building a simple web app in Go and making it serverless is very, very small difference. Okay. It's actually hard to understand what the difference is unless you look in the configuration files for Go. Okay. So this is why I'm starting with a web app to get you all used to and massaged around Go web app. It's not that difficult. It's not that hard.
No, I appreciate that. Let me sneak this question in real quick. Manuel asked the question, if we need a binding for something that wasn't on your list from 2 slides ago, what could we use? And he specifically highlights the example of event hubs.
Right. So I believe event hubs are supported, but in the case that we don't support it, what we tend to do is to bring in the SDK. And that's not a great answer, but if there's enough people that kind of wants the binding for something, we tend to be very, acute in listening to our users. So definitely, if you feel like, hey, is there a binding that I desperately need? And you should definitely tell us about it, right? Either tweet to myself or to you, Christopher, because we know the serverless team really, really well, right? And we can definitely bring these kind of requests to them.
Absolutely. Yep. Yeah. Okay.
Just to reiterate, we had just seen a web app in Go. We saw that it was 16 lines of code. So we're thinking, okay, how bad can it be if it's serverless? So let's talk about our game plan. How do we get there? Well, if you've ever scaffolded a function before in Azure Functions, you know that as part of what you do is to first scaffold up a function app. Once you have a function app, you want to scaffold up a function because you have n number of endpoints in that function app. So there's no difference here when it comes to using custom handlers and using Go. So you scaffold up a function and you author your code in Go. That's the second step. And then you try to listen to a specific route. And as the fourth step, you try to handle the message, which essentially means you're going to read the message and do something with it, which could be printing it or writing it towards a binding. You could also be returning a response. Now, returning a response is not a thing you must do. This is optional. If it's the web, it's very customary to return something. But let's say it's a queue message instead. You don't actually have to return back a response to a queue because the queue shouldn't really know about you. So it doesn't make any sense. But the sixth step that I'm about to show you a bit later is to compile your Go code because you need it to be ones and zeros. You need it to be that executable. And before you come as far as running the function, you need to configure it. And I'm going to show you exactly how you need to configure because it's not a lot, but you need to know how. So looking at a very, very simple project, if some of you have built Azure Functions before, you will probably recognize a few of these files. But what we're looking at after scaffolding is a function endpoint. Now, if you've authored an Azure Functions before in C#, it doesn't look quite like this, but you rather have dedicated C# files. But if you've authored it in JavaScript and TypeScript, this is what you're used to. You have a route subdirectory, and inside of that route, you have a function JSON, and you use that function in JSON to configure things like triggers, bindings, how the route pattern should be. Usually, you're very good with the default values of the route pattern. You also have a host JSON file, and this is very important because this one is going to talk to your serverless host. And you have a local settings JSON, which is a great file to use if you got some local settings, for example, to connect to various data sources. And you end up usually to push those to the cloud to your app settings. For example, you have a connection to a database and you want to have a connection string. Local settings is a great place to put it. And now you have the server.go, which is our web app. And if you're on Windows, if you compile the server.go file, you're going to end up with a server.exe. But if you're on Linux, that thing is just going to be called server. So I just want to emphasize that you probably have a code file, and you will definitely need to have an executable, and that thing will be produced once you compile it.
Okay.
So server go, server exe. Now, just to show you that the difference between the two apps is not that big, here you're looking at two pieces of code from the same code file. I just wanted to split it up a bit so it's easier to see what's what. So if you look at first here, we have our func main. This is our entry point to any Go application. One thing we need to know about custom handlers and using Go in serverless is that it reads towards a very specific port. So instead of you entering port 3000, you go towards this environment variable that the host JSON knows about. And it's called functions underscore custom handler underscore port. That's all you need to remember. You don't need to care about the port. Azure Functions will handle this for you via this parameter.
Okay.
And next thing to happen here is that you set up the route. And you can set that up into anything you want. There's a thing with routes and HTTP that I need to put an emphasis on. And that is that for web apps that only accepts HTTP trigger messages and only writes back HTTP messages, you use something called port forwarding. And what this practically means for you as a developer is that if you've authored Azure Functions before, you know that you usually don't need to specify /API, right? You just specify /products. By me being very explicit here, that means that I'm enabling something called port forwarding. And that forces me as a developer to be very explicit about what I want my full route to be. This is something that's only true for HTTP apps. It's not true for if you're dealing with database triggers or queue message triggers. So yeah, this is really a implementation detail, but it does affect you as a developer. So I just want to mention that. Okay. But I will show you that configuration, so you're not going to be like, oh, but how do I configure port forwarding, right? I will show you. Okay, so this is just your HTTP server being up and running, right? You're saying listen and serve to a certain port. So at this point, this is a one-to-one, between a web app and a serverless function app in Go, right? And here we have our handler function. The first thing we see is parameters, right? We see a response stream that we can write to, and we see a request stream that we can read to. And this is when a user does a request, they might fill in a body if they're doing a post, or they might have something on the URL in your browser where they input parameters. So what I'm doing here is first I'm setting the content type. And when I set the content type, this is for the client, so the client knows what type of content is coming back, so it's able to parse that correctly, right? I set that to be JSON. You can set that to be HTML text if you want to. I just did this to show you how to deal with JSON. Mm-hmm. This endpoint could potentially serve both a get and a post. So here I have an if that I say, if you're a get, just send me hello world back. But if you're of type post or some other HTTP verb, I'm going to attempt to actually read the body. And the body is a thing that, for example, if you do a web request, you can send JSON or you can send text or a file, whatever you want to put in there, right? And then I end up writing the body back to the user so they see that their post was okay. So this is a fairly simple code, right? Handle a get or handle a post, depending what it is, we end up returning different things. All of this, so I'm going to take a little poll here from you, Christopher, and see, how do you feel about it so far? Do you feel like you're still looking at a web app?
Generally speaking, yeah, that it feels relatively natural to me, that I can see sort of that normal setup down at the bottom, bringing in the port variable, and then telling it to go ahead and listen on that port, pointing it at then at the handler, and that handler does look relatively familiar to me. That I can see how it is that I'm going to send information out and how I'm going to read information in. So yeah, so it feels familiar to me. Yeah.
Super. So do we have any questions about this part, or shall I keep going?
The only little question that I have is just the asterisk that's next to http.request. Does that mean that parameter is optional?
The asterisk next to, sorry?
Next to http.request on the hello handler parameter list.
Oh, yeah, that one. I believe that means it's optional, yes.
Okay.
But you do need to, I mean, you don't have to read from the request object, right? You
Right.
can actually just, so I mean, usually when you have a web request, you tend to be interested in what's coming in, right? Either it's on the URL or on the body. So yeah, I think that's a great question. So let's move on, right?
Yeah.
I said that, okay, these two apps look the same way, right? I said, or I think you kind of confirmed and said, oh yeah, okay, it still looks like a web app. But what's the difference? The difference is the configuration file. So as part of those files that you get when you first scaffold your app, you get the host JSON. And what it wants you to do is to add this portion in host JSON. This is actually added for you if you select a template that says custom handler. So it adds this entry in that JSON file that's called custom handler. And I want to put your attention to this property because you need to populate that. This one ends up being an empty string to start out with. And this is where they can find your executable application. So you remember a few slides back, I said it's called server.exe. In this case, I've taken it and I compiled it on a Mac, in which case it's not called server.exe, but it's rather called server. What I do need to specify though is where do I find this? So if you want to put that executable file under a source directory, you can do so, but you need to do is, in that case, /.source.server, right? So it finds itself all the way to that executable file.
Uh-oh. No, you went away for a second and now your screen is just black. Yeah, let me go look. Oh, weird. Okay, hold on one second. It's still showing you here. Give me one moment. Oh, wait, now you're back. Huh.
Oh,
okay.
Perfect.
Right,
so maybe I can just reiterate what I was saying.
Yeah, go ahead.
So we're in our host JSON file, right? Host JSON is one of those files I get by default when I scaffold the function app. This is how we tell the serverless engine about important things.
Yep.
So one of the things I need to tell it about is something called the default executable path.
Mm-hmm.
This is the path to where your executable lives. So if you populate this with a value and tells it this subdirectory or at the root, if you want to, and here's my executable, and this is what it's called. If you give it all that, it's going to be very happy with you.
Okay.
And the reason I'm not naming it server.exe is because I compiled this on a Mac. If I had been on a Windows machine, I would need to have specified the full qualified file name, server.exe. There's another property here because for this time around, we're dealing with HTTP. And I need to enable this port forwarding for it to work properly. Otherwise, it's not going to find my endpoint. So once I enable this configuration, that means that whatever route that I set up, it needs to take you all the way from the root, right? Which means /API/ whatever your endpoint is called. This is a HTTP only thing, right? But you need to enable this too, or it won't play well with web.
Okay.
Oh, let's see here. Okay, so here we actually have a little demo because I wanted to show you all how this would work in real life. So here we have a little pre-recorded video that I have. What you're looking at here is a scaffolded function, and it has host JSON, local settings JSON. It has this hello subdirectory. This is a function endpoint, and it has a server because I compiled this on a Mac. It doesn't have a .exe ending, and it has the server go. And I wanted to show you how to run this function. So if you're looking at this now, you can see that I'm running func start, which starts the app. I get this annoying warning message. You can just ignore it. Once it's done, it's going to show you this is the endpoint. And once I click that endpoint, you can see that it says hello world. And you can see that this works well. And we have API hello defined. We are reading from the specific environment variable. And that's pretty much it, right? So by using the Azure Functions core tools, we're able to get our function up and running. And because this works because we have our executable server with no .exe because I'm on a Mac, and we've set the configuration correctly so it knows how to find that executable. And that's pretty much it, how to get your app up and running.
Okay. So then how do I get that into Azure?
Yeah, very good question. So normally what we do when we try to get things into Azure is to right-click publish, because we can there's definitely an Azure Functions endpoint. So if you download that for Visual Studio, Visual Studio Code, that's going to help you to set things up. And the way that we host Azure Functions is via storage. So you need to make sure that you have a storage account pointed out as part of your configuration. But the first time you kind of right-click publish using the Azure Functions extension, it's going to say, hey, do you want me to create a storage account? If you say yes at that point, or you pre-select a storage account that already exists, it's going to be happy and it's going to end up deploying that app. So that's the simple scenario. The little bit more complicated deployment scenario is using some kind of CI/CD pipeline. That's if you use Azure DevOps. But probably a simpler scenario, if you don't have a big company behind you, is to use GitHub Actions. There's definitely a GitHub Actions that you can use. That's I don't know if folks have heard of GitHub Actions, but in GitHub Actions, they are a YAML file and they contain instructions for how to build and how to deploy your app. We definitely have templates that's pre-filled, that's ready to go, and you can just add that to your project, and it's going to use that action to deploy towards Azure. So that's a bit more grown-up version once you go from this stage of experimenting to working for a company.
Okay, fair enough. That old friends don't let friends right-click deploy.
Yeah, exactly that. But I mean, that's totally fair to do if you're just starting out, right? Oh, yeah. We don't want to be these gatekeeping folks, but yeah, definitely that's one of the jokes we go with.
100%. I do want to mention we've got about 5 minutes left before we close out. But I know that I see that you've got Q-Trigger on, so why don't you talk about Q-Trigger there?
Right, great. Thanks for those 5 minutes. I have to make sure to cover what I want to cover. So we've shown HTTP trigger, right? And it works in a certain way. So I think we've driven home the important point here. What's different with a Q trigger is that it doesn't speak HTTP protocol. And what I wanted to show, if I had a few more minutes, is the fact that we can make this work fairly simple. And the main difference is that we go into a configuration file and just change from HTTP trigger to Q trigger. To be able to work with queues locally, we would need something called Azure Write, which is a CLI tool that helps fake the fact that we have a queue. Because normally a queue exists on a storage account in Azure, right? But we don't want to spend any resources at this point. We want to be local devs. So we can download Azure Write, we can start that thing, and that enables us to, one, create a queue, and two, also to fake a queue message so it can hit our working function app. But yeah, I'm going to be a bit quick about this. I just wanted to show you that binding. So when you have an HTTP trigger, you normally have a set of bindings, right? Instead of it being of type HTTP trigger, it's called Q trigger. And one other thing we do is that we need to point out a connection. And this connection is your connection string to your storage account. Now, if you work with this locally, if you have a look here, this is what the value needs to be when you work with it locally. So this kind of fakes the fact that we don't have a storage account in Azure, but rather we have this local Azure Write, and we have another tool that you might know of, which is called Azure Storage Explorer. Now, Azure Storage Explorer is a great app that enables you to browse all your resources in the cloud. And one of the things it also does is to show you an emulator. And in that emulator, you can set up a queue, you can create a message that's able to hit your code.
And this is a really important point that you're highlighting here, is the fact that I can do all of this locally. So I can simulate those Azure resources locally before doing my deployment. So I'm not paying, I don't need an internet connection, I don't need to be connected to the cloud, that I can do all of this locally with a couple of add-in tools.
Yeah, for sure. And I think that's a very important point you're bringing on, which is developer experience. I mean, as a developer, long before Microsoft, I've always thought I want to work in isolation, right?
Yep.
I want to mock my endpoint, mock my databases, and I definitely don't want to pay any, cloud credits when I'm developing, because I'm testing a lot of things. And if I end up with a cloud bill, I'm like, I don't want that.
Yeah, exactly.
So if we just quickly look at the Q trigger here, we can see that it looks very similar. I mean, this is the exact same code that we're using. The only difference is we don't have /API, but we have, API is understood, right? And we say in queue trigger instead. And then we're setting up our server. And I just wanted to show you what the queue message looks like, because this is a piece of JSON. So imagine that you have a piece of JSON that this is coming from either a real queue or an emulated queue. So you have the data portion, which contains your queue message, and you have a metadata portion, which is very queue specific. So these are things like, what is the queue call? What is the endpoint call? When did this happen? This could be super interesting for your app, but normally you care mostly about this because this contains your queue message. Now, your queue handler needs to do a few things. It needs to map whatever is incoming here. So if you look at the top here, you see that I created a struct. You can think of a struct almost like a class, right? And it contains a few properties that emulates what your incoming message looks like. So it contains data and metadata. And so once we have our request, we want to decode that, because at this point it's ones and zeros. So we want this to turn into some readable text. So we decode it. And then we use our JSON library to drill into that message and say .data.queueItem. And this is exactly like going into here, right? .data.queueItem. And at this point, I have the message and I'm able to print it.
And that's very similar to how you would do that in Python.
Yeah, exactly. So, and you're looking at 7 lines of code, and you're able to say, hey, I have a queue message, and this is what it looks like on the console.
That makes sense.
So yeah, just quickly show the Azure Storage Explorer if you've never seen that before. If you have Azure Write up and running, it means it's going to marry itself to Azure Storage Explorer. It's going to give you this emulator node. On that node, you will have a queue node, and you can just right-click it and say, I want to create a queue with a certain name. And once you got Azure Write up and running, you can either have it up and running via VS Code, or you can just npm install it. So you would need Node.js pre-installed. And then you can either start it via VS Code or on the command line using this command here at the bottom. So once you have Azure Write up and running and installed, it's gonna integrate itself with Azure Storage Explorer, and you're gonna have all that local emulator functionality ready for you to use.
That's fantastic. And it's worth highlighting, this works on Linux and on a Mac.
Oh yes, operating system independent. I tried this on a Mac, and all of these software that we're mentioning right now, they do exist for Windows or Linux, whatever you have.
Yep.
And just wanted to show you, once you are in items in your queue and you highlight that, you can just press add message. At that point, you're going to get a modal up, and you just type in that modal, you hit OK. And if you got your Azure function up and running at this point, it's going to consume the message. It's just going to say, thank you for that message. I'm going to print on the command line, because that's what our function was told to do. So that's how straightforward it is, I would say, to work with either HTTP triggers or queue messages. So it's not a ton of difference, and it's the same lines of code, thanks to triggers and thanks to bindings that does the heavy lifting.
Fantastic. That was great. That was a great intro into Go, and it was a great intro into serverless and into functions and some of the different ways that we can call that. I greatly appreciate it. Where can people, A, find you, and B, find out more information about Azure Functions and Go?
So you can Google Azure Functions and Custom Handlers. I should have had a direct link to show you all, so you could have gone and clicked that directly. But let's see if we can add that as a comment on your stream, right, Christopher?
Yep.
And there's definitely a very good page on our docs that shows how to do this. And I can tell folks right now that I'm actually writing a Learn module. So in a week or so, you will have it published on Learn, and you're going to be able to do all of these scenarios yourself.
Perfect. Thank you. And you can find Chris at Chris_Noring on Twitter. And I'm certain not to put him on the spot here, but he will tweet out when that Learn module is released. And you can find me, of course, at Geek Trainer, which you can see just down below me. Chris, thank you so very much for joining today, coming on and talking about Go and Azure Functions. It was fantastic to have you on. Thank you so much.
It was my pleasure. It was really fun to be here. And I hope folks learned something and got their questions answered. So yeah, super fun.
Thank you. All right, and we will be back next week here on Web Wednesday. Thanks again. Bye.
Thanks all.
Cool. All right, and we are